Hey everyone. So in this video, I'm going to talk about distributions of data, specifically box and whisker plots again. So we're going to review how to make a box and whisker plot by finding that 5-number summary. But then we're also going to learn about how to find something called an outlier. And then we'll also figure out how we can describe the shape of the distribution by not just using a histogram like we did last time, but by using the box and whisker plot as well. So that's what we're going to be doing in today's video. So first, let's review the different types of distribution that we can have. So these are all called histograms, which you might know the term bar graph, but that's the fancy word for a bar graph. And if the two sides of your graph are relatively similar, then we describe that as symmetric. If the left side sticks out more, we describe that as negatively skewed or skewed to the left. If you prefer that language, that's fine. Either skewed to the left or negatively skewed. This over here, if you have a longer section on the right, we describe that as positively skewed or skewed to the right. What we're going to do is we're actually going to change some of our instructions here because we've practiced making histograms. We're going to focus today on box and whisker plots again. And we're going to use this example about the amusement park. So we've got Elisa recording the amount of time in minutes that she spent waiting in lines for rides at an amusement park. So the first thing we do when we're making a box and whisker plot is we write the numbers out in order from smallest to largest. So I see a 1, I see a 2, I see a 4. So you're just going to keep writing the numbers out in order until you have all of them. I'm going to pause the video for a minute to do that. Okay, so now I've got the numbers all in numerical order. The shortest time she spent waiting for a ride was 1 minute. The longest was 89 minutes. So we're going to come up with our 5-number summary like we had learned to do before. So we have a min, we have our quartile 1, which is the half of the bottom half. We have our median, quartile 3, and our maximum. So let's fill in our min and our max first. Our min is 1 and our max is 89. Now we want to find our median next. We want to split this so that we're finding the middle number. So let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So she went on 26 rides. So that means we need to split it 13 and 13. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our median is 20.5. When we have an even amount of data, we take the two that are like on either side of the middle and average them. So our median is 20.5. Now we want to find quartile 1, which is where you focus just on the bottom half of the numbers. So let's count how many of those are. Oh, there are 13 of them, right? So we would need to find the middle of those 13 numbers, which would be this 12 here. We have 6 numbers to the left of the 12 and 6 numbers to the right of the 12. So quartile 1 is going to be 12. Now we'll do the same thing on the top half. We have 13 numbers, so we'll have 1 number in the middle and 6 on either side. 1, 2, 3, 4, 5, 6. So this number right here is our quartile 3 number, because I have 6 to the left of it and 6 to the right of it. So 35. Okay, so that's our 5-number summary. That's what we're going to use to make our box and whisker plot. So let's come up with a scale for that. I'm going to move this paper, I think. So let's see, the lowest is 1 and the highest is 89. So I think I'm going to make my scale go by tens. I think that would fit nicely. So I make my number line down here. So I'll do 0. I think I could maybe do every 2 dashes is 10. Let's see, 20, 30, 40, 50, 60, 70, 80, 90. That'll fit nicely. You just want to make it fit on the page. but take up a decent amount of the page. You don't want it to be super tiny, or else the little boxes you draw will be tiny. So then we're going to label our points above that. So I'll have a 0, a 12, a 20.5, a 35, and an 89. I'm actually going to do this in pencil. There's a reason I'm doing it in pencil. So you should probably do that too. These dots are okay to have in pen. But when I do this part, remember the middle 3 make the box part of box and whisker. Okay. So, oops, one more line I forgot to draw. There we go. So that is my box and whisker plot for this set of data. There's actually a little bit more that we can consider. So this is review. We have done this before. Now we're going to talk a little bit about a couple new things. One thing that's kind of new, range. We did discuss this on Friday. Range is the highest number minus the lowest number, 89 minus 1. So our range is 88. There's also something called the interquartile range. Interquartile range. That's how you say that, interquartile range. This is IQR for short, interquartile range. And the way to find that number is to do quartile 3 minus quartile 1. So instead of doing max minus min, we do quartile 3 minus quartile 1. So 35 minus 12. So that will be 23. So our interquartile range is 23. What that means is that half of the data is within 23 units of each other. 23 minutes in this problem, because it's talking about the minutes we waited. So half of our data is within 23 minutes of each other. The rest of it is spread out on the ends. So basically we're saying half of the data is between 12 and 35. The other half are beyond those. That's what interquartile range is measuring. Now we can use the interquartile range to find what we call an outlier. An outlier is a number far outside the range. Well, far outside, not the range, far outside, let's say, the interquartile range. It's far outside the interquartile range. Well, how far is far? How do we determine if something's an outlier? Is the 1 an outlier? It's kind of far. Is the 89 an outlier? That's really far. But is there some sort of rule? Yes, there is. There's a rule. So an outlier is either going to be greater than greater than quartile 3 plus 1.5 times the interquartile range, or less than quartile 1 minus 1.5 times the interquartile range. So basically we are seeing, okay, is it really far above quartile 3 or is it really far below quartile 1? So let's do that for this problem. We're going to calculate where both of these thresholds will happen. First, to do that, we need what 1.5 times the interquartile range is. So 1.5 times the interquartile range, well, the interquartile range was 23. So 1.5 times that is going to be 34.5. So that's the first step that you'll do for this. You'll figure out what 1.5 times the interquartile range is. Then you're going to take that number and add it to quartile 3, but subtract it from quartile 1. because we want to see if we're bigger, like are we way bigger than quartile 3 or are we way smaller than quartile 1? Well, what was our quartile 3 number? 35, right? So if we add those together, we get 69.5. That is the threshold where anything above this is an outlier. Do we have any numbers that are above 69.5? We do. We have 85 and 89. So 85 and 89 are both considered outliers. Well, what about on the low end? Do we have any numbers that are below quartile 1 minus 34.5? Well, quartile 1 is 12. So if I subtract, I'm going to get a negative number, which that doesn't make sense because you can't wait negative minutes for something. And so no, we don't have any outliers on the low end, but we do have a couple on the high end. So how do you deal with those outliers? You may have noticed one of the graphs. Oh no, it doesn't show it. Never mind. I thought one of the graphs had an example of that. How you show outliers on your box and whisker is you actually now make your whisker end at the last number that's not an outlier. So this is the new end of our whisker. So we're going to erase and we're going to put 64 as the end of our whisker now, but we do still plot these points. They're just not connected to the box and whisker. So they're going to look a little bit like this. There are some differences in style. Some books will connect these with a dashed line. They'll put little dashes going out to these. Some books just leave them as dots. We're going to leave them as dots. So if you have dots that are alone out there, that indicates that they're outliers. So that's how you adjust your box and whisker graph to have outliers involved. The last thing we're going to do is describe this distribution. It went all the way out here originally. So this whisker on the right was really, really long compared to the rest. So that's very similar to this idea here, where it stretches out more on the right. And so we would describe this as positively skewed. So that's the last thing we're going to write down. This is positively skewed. So you basically look at which whisker sticks out the longest. If the whisker on the right sticks out the longest, that would be positively skewed. If the whisker on the left sticks out the longest, that would be negatively skewed. And if the two whiskers stick out about the same, like this example here, both of these box and whisker plots look like the whiskers stick out about the same. We would describe that as symmetric. So here's a symmetric example. Okay, so you basically judge by where the whisker is on what to call it. Okay, that wraps up this video. Make sure that you get the assignment from the teacher and you have the rest of the period to work on the assignment. On the skills practice side, you'll do problems 1, 2, and 3. And on the practice side, you will do problem 1. You are going to find the following things. You are going to find the 5-number summary, the interquartile range. You're going to draw a box and whisker plot. You're going to determine whether there are any outliers and describe the shape. The same things we did in the notes. So ignore the instructions that are there and do those things for each of the 4 problems. And that's the assignment for today. Thanks, guys.